for camera.
Alright, so, oh, sorry. We are RescueR, autonomous rescue robot. This is TATAX 2021. So thanks for our sponsors, Symbol AI, Jambons, Telnix, Iowa, and Subspace. And, next slide. So our problem domain is, I don't know if you guys have heard of the Miami collapse building about a few months back. The building collapsed, there were, it was a catastrophe. There was a lot of missing persons cases. There was no way to actually figure out how to actually respond to the situation because we never had anything like this. And so how do you figure out where to find somebody, how to dig up which rubble in order to find that person and bring them to immediate attention. So this led to a lot of deaths. There's also rescue routes that are too big to navigate in such a space and avenue. So we wanted to kind of go through this domain and figure out hey, can we build something that could make this situation easier when we have to respond to a first case incident like this. And so our solution is called the Autonomous Rescue Robot, or RescueR for short. So if you go back, if you go back one slide. So what we're going to be doing is we have first responders, right? And those first responders, we're going to equip them with a iPad or a device, and they can go on an application that lets them control this robot, and then right here, and then the robot is going to be something like a Boston Dynamics dog. We actually have a smaller dog that's like that we kind of can demo a little bit of it.
It's more of a cat.
It's more of a cat. But in any case, we have a proof of concept and a prototype that we can use to kind of showcase what its feature sets are for the bigger applications. And then then the long-term goal is to use this robot with its advanced feature set to help in search and rescue operations. So here's our demo, and I'll hand off to Muntaser.
All right, so basically our aim for building this robot is to reduce the latency it requires for emergency responders to get to hotspots where people might be trapped or they don't have access to. So for example, if there's a building collapse and there's rubble or there's an earthquake, rescuers need to get to people where they are, and they need real-time communications. So joining these two together, we've developed a prototype bot. This is basically sitting in the other room because we're going to show you a little bit of the functionality. If you can play the... So it has quadrupedal locomotion, so basically you can walk on all four legs. Right now it's a prototype thing, so it really falls up, it kind of falls over. But what we were able to do is, proof of concept wise, this is battery powered. It has a bunch of onboard sensors which are relevant for emergency rescue. Things like a microphone, it has a speaker, and essentially it can act as a voice relay unit. So imagine someone trapped under rubble. You can send the rescue robot in and have a line of communication with potentially people who are trapped under debris. So you want to go next? All right. So it has onboard cameras and imaging systems. So we're gonna show you that in a couple of seconds. So via text, using our sponsor APIs, we're able to control the actions of our bot. So we can send text commands like get it to move to a certain place, get it to give you the field of view of whatever the sensors are seeing. So here, if it, for example, sees a sign, it can look at it, and you get a text back with an MMS saying, this is what I'm seeing right now. Moreover, we can get different readings from the sensors. So there's a thermal camera equipped there. If there's a fire or there's excessive smoke, we can detect alarms which are relevant to these conditions. Next one. Right. So we also have real-time video. So you can actually make a conference call or a video stream with someone who is potentially trapped. and this is done over Agora.io, and we have the ability to stream live video from the bot and communicate in real time. We can get the transcript off of this using simple AI. Next. Okay. Yeah, so you want to talk about two-factor authentication? Yeah, so two-factor authentication, we use Telnex's two-factor authentication in order for the real-time emergency responders to be able to access the bot at any time. So this way we are allowing multi-access to a single point of operations, and we can do that via either phone call or via SMS. So essentially you get access to all the robot functionalities as if you are logging into our website. Next video.
Yeah.
No, it's on next slide.
Next slide.
Next slide. Or I guess not.
Yeah.
No. Also, this is our. Do we have other slides, other videos, or is that it?
No, I think that's
Okay. So this is like a big picture of our engineering architecture. So we have the first responder interface, which is going to be like a website in this case. It could be also a mobile device or an Android app or an iOS app. But what it has is it has different controls for like a D-pad setting. So you can control the robot up, down, left, right. We're going to incorporate other features, but we have to scrap it. But this is the core feature set. And then you have the web RTC camera, which this is actually on the dog itself, and it's facing towards whatever the search and rescue operation is happening. And so the main premise of the architecture is this connects to our backend API, which is a layer that handles all the communication protocols from the database, which where we store information related to what sensor data we're gathering there, whether it's smoke data, temperature, CO2. We also have down the pipeline a way to also do sensory measurement of the area, like sensory detection.
Right, so the one thing we weren't able to completely do is we actually have well, we ran out of time trying to do like a microphone array. So essentially locating or echolocating where somebody might be asking for help and locating them via multiple microphones. So essentially it's like you can tell where a sound comes from because you have 2 ears. Mm-hmm. And that was the same concept that our next step is to apply here. Effectively, we kind of ran out of time to do that, but
yeah.
The idea here is essentially the same as relaying a call. And in addition to it relaying a voice call, it would also tell you where this sound is coming from or where the person is. Because usually in rubble, like if you are under a building or trapped, you don't have access to GPS, so GPS is kind of useless. But you can use sound to kind of say, oh, the sound is coming from X direction or Y direction. And the way to do that is you have multiple microphones in this to do like a beamforming of the audio that comes in. Next. Okay, so on the technical side, the controller for the Raspberry Pi or the robot is a Raspberry Pi. This has all the code and all the communications platforms reside on the Raspberry Pi. The Arduino controller does basically most of the motor stuff. We have 8 servos for leg locomotion. We have a servo on the neck area for panning the camera. We also have an ultrasonic sensor for object and for obstacle detection. And then we have a thermal camera which detects fire or hot spots where rescuers would be advised caution to go into. Next.
So this is a little bit our backend architecture, just how our interface happens from the front-end responders application that they're looking at for controlling the dog, as well as for the web interface to the actual dog itself. So we just have different endpoints for getting data from the dog that's collecting it to our database. Locations is like specifically where it's moving towards and like what areas of interest are around its area. Robot status is whether it's on, whether it's like autonomous. If we had a future setting that we were kind of planning in the event that you want a dog to kind of like run around the circle and just scan the area, for instance. So we can check a robot status or like its internal settings. Then we also have one for actually setting those settings right here. another for just getting specific data related to nearby areas of interest, and then this is for actually controlling the dog itself from the web interface to the dog.
Okay, so just a quick, if you go back to the slide.
Yeah.
Okay, so just a quick, quick note on these. All these paths to control and getting data are all implemented via, like, you can have texts that do all these things. So the entire platform can be controlled via either app or text, and in the future via voice.
Yeah.
Next.
This is just an example of our data storage, how we're capturing the data, and this is one example where we're capturing the inputs from like the up, down, left, right, from the user to the dog, and that's what controls the dog. So basically what's happening is we're sending this data to the database, and then the dog is reading the latest entries from the database. And we have also different tables here where we're storing data related to logging in, related to security, related to data infrastructure or location data.
Quick word on how we implemented this stuff. The tokens, that comes in from the two-factor authentication you saw earlier. So Telnix gives us a way to do two-factor authentication. So what we need to have is either an SMS-based verification for the ER or a registered phone number that the ER responder who's controlling the dog would have. So either of these two ways work. This is basically shown in the video like a few slides back. And apart from this, all this other data is real-time updated by the system, and you can query it via text. Okay. Okay, so how did we use all the sponsors? So Telnix and Jambons were basically the main communication platforms used. So all the texts that can control all the activities we saw, they're mainly Telnix.
Calls.
Yeah. And well, the texts and the calls were all Telnix and Jambons together. So Telnix more, it's kind of, we found it, especially because we had the two-factor authentication, the flow was much more smoother in Telnix. Jambons was actually, it was actually pretty surprisingly easy to set up because they have a Node-RED plugin. So all we did is just threw together all our endpoints in Node-RED. We have a diagram of that afterwards. Symbol.ai, we used a real-time transcription. So basically, if we had someone talking or like a message that needed to be relayed, we could actually do out that message and then translate it to different languages and have the dog speak different languages. So obviously, if you're in a multicultural place like Miami, the responder will maybe not speak all the languages that the person needing to hear understands. So that's why we kind of thought of having real-time transcription and then a translator backend, and we can do notify by text. So for example, we're going to show you that right now. If you send a notification, the dog kind of talks. Okay, subspace was the most interesting challenge for us because this actually is very geared towards this kind of scenario. Subspace is used for low latency data transfer. So we set up like a toy packet accelerator. So obviously our last hop is the Wi-Fi network, so we're always bottlenecked by that. But we did manage to set up a packet accelerator where we sent out basically a stream of bytes. In our case, it would represent the real-time data that's collected by the sensors coming in. So that would potentially be updated faster than any two-way communication or messaging between the robot and the RescueR. AWA network, we didn't really use much of it. All we did was we compared what would cost to send the message via Telnix or via Twilio. So we set up a Telnix and a Twilio route, and we kind of got a comparison of, if you control the robot via Telnix, this is how much it would cost. If you control it via Twilio, this is how much it would cost. And finally, the real live streaming video, we used Agora.io, and we basically used the WebRTC platform for getting real-time video. Next. Okay, so this is the Jambons flow that we're talking about. So we basically had our messaging and calling verbs from Jambons, and we had we had basically webhooks integrated into our backend. So pretty much all of it is like a REST architecture. So using Node-RED, it was pretty easy once we had the architecture all set up to just plug and play everything into Node-RED. So if you guys are familiar with Node-RED, I would suggest using Jambons in this way. Next slide.
Excellent.
And this is our team. So we're gonna, before we go up, we're gonna show you a couple of things. We're gonna do the notify and then.
Yes, the notify.
All right.
You know?
All right, so I'm going to send a text to the bot.
Can we all text it?
Yeah, you can. Actually, I will.
Better turn to the TFA, that's gonna be a really confused bot.
Oh, what is the audio?
Yeah, is there a way we can get the audio from the machine up there?
Yep. Look, let me just, because I turned the audio down before. Now, if you're pumping your audio out through the HDMI, it should be there.
Remote tasks. Cover notification sent. Notify the remote tasks. Cover notification sent. Notify the remote tasks.
They can also pictures.
We need a Cookie Monster voice pack.
So-
That's all we need.
So this is the number.
Well,
407.
just so I can explain it, like, what do you actually send?
Notify, and then whatever you want them. The box.
So she's sending notify and then the message of, is that what he says?
Yes.
Yeah,
that's
what you send after the notify
So
would be what he
basically, what
actually
the
sends.
rescuer would send out this text.
And then what's the next one? We just,
Yes, there it is. So the last picture that the bot took. Okay, this is.
Yeah, you can show the camera.
I put it
Yeah,
sideways.
no, just walk up to the camera so you can show it on the,
Yeah, that camera, the left one.
from the computer you can see.
and that was her sending a command to take a photo.
And yeah, if you guys want to try it too, the number is 407-305-0867.
305-8067.
305-0867.
Oh, 0867. Okay.
So you have to type in notify and then
Aye.
just type whatever.
Cover notification sent. Notify I.
They said
Cover
that.
notification
Yes,
sent.
I said hi.
Notify I.
Now that photo.
Well, what do you want me to have it say, Vincent?
Say.
Sulu. Notification sent. Notify Sulu.
Someone's
Notify
asking.
Sulu.
Say all
So
your
you are in my
baseball and
SRF.
All you guys belong to me. On to the next item.
I think our
Cover
robot's becoming
notification
sentient.
sent. Notify your trouble to the next item. Cover notification sent. Notify your trouble to the next item.
You could showcase the live stream.
Yes.
I'll do,
And
Okay, we're sort of getting over
here's,
time
and
now.
here's another photo that we took.
Do you want to go to browser for this one?
Is there anything key? Because we're sort of like running a bit long now.
Let me.
Your trouble to the next item. Cover notification sent. Notify me on the
Okay.
I think that was it. Yeah.
Cover
Perfect.
notification sent. Notify
Yep.
me on the
That was excellent.